All right, guys, and welcome back to this second part in the category where we are hacking flash loans. In this part, we will actually perform a arbitrage with a flash loan. I already explained to you what an arbitrage is. That's basically a difference between two prices on two different exchanges. For this, to make this example possible, we forked Uniswap the Uniswap contract, and we duplicated it. So we created a Uniswap version 1 and version 2. And between those two versions that we deployed ourselves and that are basically on a test network, we created two different prices so we can actually arbitrage. And now we're going to use these arbitrage opportunities and we're going to exploit these arbitrage opportunities with a flash loan. We basically expanded the simple smart contract with arbitrage functionality. And now Rob is going to explain more in depth of what function we add and what we needed to do to actually make this arbitrage work for us. All right, Rob, so now you can take it away. Yeah.
Okay, hi guys. Let's try to do an arbitrage. We are going to trade between DAI and BAT. So in order to do that, we need 5 steps. The first one is borrowing DAI from Aave as a flash loan. Second one is buying BAT with the DAI that we just got borrowed. Third step, selling the BAT, the selling BAT for DAI in the second exchange B, and then we can repay the Aave loan. And if we profit, we get the profits back to our wallet. If not, the transaction is going to be reverted. Okay, so I'm going to walk through all the steps here. First step is you need to declare the token's address that we have here. So the DAI address, the BAT address, our Uniswap factory contract A, and our Uniswap contract B. The DAI, just to remember, the DAI address and the BAT address we get from the Aave's documentation. If you go to the Aave market, you can check the reserve assets over there, and then you have like the DAI address on Kovan. Don't forget to check Kovan, and the BAT address here. Okay, so first we need that. Second thing, we are going to just set the pointers now for the lending pool for the exchange A, exchange B, Uniswap factory A, and Uniswap factory B. Then we are going to set our constructor function, and you need to initialize the Uniswap factory A, passing the Uniswap factory address. And then we are going to get with that the exchange A address, calling the function get exchange and passing the token that we want to find the exchange address. And with the exchange A address, we are going to initiate our exchange A contract, passing the exchange A address that we just got here in our second interface. So, but we don't have that interface yet. And by the way, we don't have even the Uniswap factory interface. So don't forget to import Uniswap interface for our contracts. We did a version already for you guys, so you can check import from our GitHub.
Yeah, and what's important, also what you learn from DeFi 201 or DeFi 101 is interface is basically interface into the application. Yeah.
Yep. So we are going to do the same steps, but that time with our Uniswap factory B. So you need the Uniswap factory B address and the Uniswap factory interface, so you can initiate the Uniswap factory B contract, and then call again the get exchange function with the BAT address this time. And you get the initialize the exchange B with the exchange B address that we just got. So important to mention, the Uniswap exchange A, we are going to get the exchange from DAI address, and the exchange B we are going to get from the BAT address, because that's the way that you set the price difference so you can arbitrage. And last thing, I'm going to set also the lending pool, and I'm passing this time. I'm not doing in two steps like I did this up here. I'm passing directly the lending pool address provider here as a parameter, so I'm initiating lending pool directly. Perfect, guys. So this is all the setup that we need to do in order to initiate our arbitrage, I think. Cut.
All right. Yeah.
Okay, so I can brief a little bit. Okay, so I think, is it okay for the first part?
Yeah. And now we're going to initiate it, right?
Yeah, and now we're going to explain the Uniswap functions, like below there.
Okay. All right, Rob. Yeah, that was very clear. And again, if there's any questions, just go to the forum or even issue in the GitHub repository. And now I think we still have the Uniswap functions left that we need to go over, right?
Yeah, so okay, now that we did our setup, let's go to the Uniswap functions. So now we need to trade with like the tokens that we want to trade. So here is our make arbitrage, is the function that's going to call the flash loan from the first video. But now I'm going to do a little secret here. I'm going to initiate the DAI contract, and after we do the flash loan, we are going to check for profit. In order to do that, I'm going just to check the balance of this contract here, if I have any DAI left in this contract. And we are going to do like a require function that just transfer the DAI back to the sender, to the person that just called this function here with the profit that we just made. Okay, so let's go to the arbitrage function. Okay, so first things first, we need to initialize the DAI and the BAT contract, both with their respectively address here. And first thing, don't forget you need to approve the exchange address and the amount. So you require that function here because the Uniswap function, Uniswap exchange, they're going to call a transfer from function with your tokens. So you need to approve it first. Okay, guys, so here is the, remember that in the beginning, we initiated the exchange contract. Okay, now we are going to call this function here, token to token swap input. If you check Uniswap documentation, they have a lot of different methods: token to with, token to token, token to token put, output. In this case, we are going to use the token to token swap input, and they need 5 parameters in order to work, 5 inputs. The first one is the amount that you want to input there in Uniswap. The second and the third one is around slippage. So we are not caring about this now. So you can just set 1 for the second and third parameter. The fourth parameter here is the deadline, like how long after you call this function you want this function to be valid. So you can do like now plus some blocks just to get valid, but instead of that, I'm going to call only deadline, and I'm going to define a deadline variable up here because we are going to use that same deadline in the function below. And the last parameter from this function is the address of the token that you want to exchange. So remember, we are exchanging DAI to BAT. So if you want to exchange DAI to BAT, you need to instantiate exchange A with DAI, and the last parameter should be the output token. So in that case, BAT. So just remember that upside here, we initiated the exchange A here with the DAI address because it's our input. Okay, good. So when you call this function, the function returns the amount of tokens bought, the amount of BAT that we are going to buy calling this function. After that, we are going to get this BAT that we just got, and we need to approve the BAT to the exchange be allowed to spend in our behalf the BAT amount that we have. So that's why we need to instantiate the DAI and the BAT address up here. Okay, and finally, we are almost there. We are going to call again the Uniswap function token to token swap input, but this time we are not calling from exchange A, we are calling from exchange B. That's the BAT exchange address, BAT exchange contract, sorry. And again, we have the 4 inputs, but this time the first input is not the amount that we got from the flash loan. This time, the first input is the token bought, the token that we just went through in the first step. Okay, so the second, the third parameter is about slippage. The deadline is going to be the same. Now, remember, this is a shortcut for the current block that we can access obsoleted. And the last parameter is the output that's going to be DAI again because we need to repay our flash loan. And we are going to do a spicy secret here. We're going to insert a require that the DAI bought should be higher than the DAI borrowed. If not, we are going to return an error saying that it is not profit.
Exactly. And what's really nice here is that you can actually repeat this process a lot of different times. So that's pretty cool.
Yeah. And then we are going to repay back our flash loan function. Okay, so we did it. Let's try to run and deploy our code.
Yeah, let's give it a try now. Yeah, it's really nice. So like as you see, like if we don't make a profit, we're not gonna initiate code, so we're not gonna lose gas fees or funds. So it's basically if there's an arbitrage opportunity somewhere, this contract, if you keep on initiating it, it will catch it and make you money, basically. Yeah.
Yeah, so you keep calling this function until you find some profit. Okay, so we go to the third button here, to deploying transactions. Remember that we should select the injected Web3. We are using Kovan. And okay, and then you need to select the contract that you are going to deploy. This is the arbitrager. You can check here the name. And okay, we are going to deploy. Good. Okay, so we are going to call this function make arbitrage. And to start with, we are going to borrow 100 DAI. So let's try borrowing 100 DAI. Okay, let's see if it works. And apparently works. Let's check.
Yes. So now we borrow 100 DAI and from the contract, and then it's also already going to, let's see how that plays out. There we go. Nice.
Good. Then we made 11 DAI of profit, guys. Nice.
Amazing, amazing, amazing. So yeah, let's walk over these transactions now, Rob. So now you see the contract is initiated here at the top, and then basically what's happening? We're borrowing 100 DAI. Then next step is we're going to send the 100 DAI and we're going to swap it for BET. Then we're going to send the BET to the other exchange. We're going to swap the BET back to DAI. We're going to repay the flash loan and take the profit and pay the fees.
Yeah, nice, guys. So let's see.
Nice. Yeah.
Let's see the other way around. Like, let's change the orders of the contracts here and see what happens. What do you think is going to happen, guys, if we change the order of the exchanges?
Yeah, now so instead of exchange A to B, we're gonna go from B to C, from B to A. So if you go from A to B, and we know there is an arbitrage opportunity there, but the other way around, it should actually cost money to swap it between those two pairs, between those two exchanges, right? So let's see what's happening. Normally, if you would do this, you would actually make a loss, and then you couldn't repay the flash loan. So basically, what happens normally if you remove our security function is that you will lose funds basically. So then the flash loan is triggered, you cannot repay it, so it kind of is reverted, but you still need to pay the gas fees and you need to still pay the flash loan fee as well. So you're basically losing funds at that time, and yeah, it's never nice. And as you saw, like if you do this with bigger amounts, those fees can be pretty high actually. All right, let's take a look what happened. Yeah, reverted, fail, and you can also see the nice thing is maybe Rob, you can show that the prompt fail. There is a prompt in the code that we show here. I did not profit, right?
Yeah, so as that's our safe function here. So did not profit, and then we can see the error here, did not profit. So the function was reverted and we just paid the gas fee.
Yeah, but that gas fee is like really small.
Yeah, guys, so I think that's it.
All right, guys, so that's pretty awesome. So yeah, so that we walked through all the whole arbitrage opportunities here, right? But of course, with this DeFi primitive, a flashness DeFi primitive, we can actually do much more. And you can also see in the GitHub repository, we are playing also with some other things. Like I wrote, like it's not only arbitrage that we can do, but we're also are able to do refinancing of different contracts. So let's think about a real world example. Like if you have a car or something, and you have a loan on that, you can refinance loans, right? That's a big market. A lot of people refinance loans. And in crypto, that's called a collateral swap. So let's say you want to swap Maker to Maker to eat or another setup, you need to normally go to an exchange. Like if you have a collateralized debt position and you borrowed ETH, you borrow DAI and you deposit ETH, and you say like, well, I don't want to have ETH as a collateral. I want to have the basic attention token as a collateral. So I want to swap that, right? I want to refinance that. Well, you can also do that by using a flash loan as well.
Yeah.
And I think also, and we will also discuss this in the forum, and yeah, let us know if you have any other ideas. So right now there's basically 3 use cases for flash loans, which is arbitrage, which we showed you, that's the biggest use case. It's collateral swaps, refinancing, and it's liquidations. So these 3 are the main use case for flash loans today. But I think, and do you also think, Rob, there will be more use cases maybe in the future that we don't know yet?
Yeah. We still so early, so we still in the beginning to see what is all the possibilities that we have.
Yeah, I think so as well. So yeah, that's super interesting. So yeah, guys, so like we now covered the arbitrage flash loan, and in our next video, we're going to create our own arbitrage opportunity by using the different Uniswap pools that we created, and we're going to add our own token and create our own arbitrage opportunity. And then you can also import these contracts into the contract we just showed you to actually do the flash loan. So yeah, I hope to see you in the other video, and then we're gonna dive deeper. And again, in the last part of this series, there was also an assignment to do your own simple flash loan or your own arbitrage. And if you have any questions, if you have any issues with this particular code, you can go to GitHub and you can submit a issue, and then we will come back to you, or you can interact with us on the forum. All right, guys, thank you very much, and see you in the other video. Thanks.